my name's Steven, and welcome to Physics
After Hours.
And now let's get into our question. Alright, now let's take a look at our question. The question states that we have two 65-kilogram astronauts that leave the Earth in a spacecraft, sitting 1 meter apart. Then it asks, how far are they from the center of the Earth when the gravitational force between these two astronauts are equal to the gravitational force of the Earth onto one of the astronauts. Now that we have this, let's get into the equations we need to solve the problem. Alright, here's our equation setup, and the main equation we need is equation 13.2 from the textbook, which is Newton's law of gravity. The reason why we need this is because we need to be able to find the force, the gravitational force between two different objects. And the two different objects is the force between two different astronauts and the force between the Earth and the astronaut. And we need to find when they equal each other to be able to find the distance between the Earth and the astronaut. So as for the setup for here, we have the force between the astronaut and the other astronaut, which is the gravitational constant of the object 1, which is one of the astronauts, and object 2, which is one of the other astronauts, divided by little r, which I made to count as the distance between those two astronauts. As for the force of the Earth onto the astronaut, we have the gravitational constant as well. The first object, which is the mass of the Earth, the second object, which is the mass of the astronaut, one of them, and big divided by the big R, which is the distance between the Earth and the astronauts. So we have to find the distance between the Earth and the astronaut when the gravitational forces are equal. So if we make them equal, we see that the gravitational constant cancels out, as well as one of the masses of the astronauts, leaving us with the mass of the astronaut divided by the distance between the two astronauts squared, equaling the mass of the Earth divided by the mass of the distance between the astronaut and the Earth squared as well. So this variable right here is what we need to find, because we're supposed to find the distance between the astronaut and the Earth. So if we isolate this variable right here, we can get r squared equals the mass of the Earth divided by the mass of the astronauts multiplied by the distance between the two astronauts squared. And to get rid of this squared here, we just square root the whole problem, leaving us with the distance between the Earth and the astronaut equaling the square root of the mass of the Earth divided by the mass of the astronaut multiplied by the distance between the two astronauts. So with that, let's get on to the calculations. Alright, now we're at the calculation step. Here we have the function we have from the last step, and now all we have to do is take the information we have from the question, as well as do one quick Google search, because we don't have all the information we need to solve the problem. The information we have is the mass of the astronauts, which is 65 kilograms, as well as the distance between the two astronauts, which is 1 meter. The information we don't have, which is the mass of the Earth, which I just did a quick Google search because I was too lazy to check the book, and found out that the mass of the Earth is 5.98 times 10 to the 24 kilograms. Now all we have to do is plug in the numbers to their respective variables right here, which is the mass of the Earth divided by the mass of the astronaut times the distance between the two astronauts, and we get approximately 3.03 times 10 to the 11th power. And to figure out the units, as you can see, we have kilograms divided by kilograms multiplied by meters, and since kilograms with kilograms cancel out because it just equals 1, we know that the answer is in meters. So there you go, that's our answer.